Hello, everyone. Today, let's learn about the definition and characteristics of thermal resistors, as well as the commonly used materials for thermal resistors. First, let's understand the definition and characteristics of thermal resistors. In fact, the resistance values of various conductor materials change with temperature. The working principle of a resistor temperature sensor is to calculate the temperature of the measured object by measuring the resistance value. Generally, the temperature measuring element made of metal conductor, such as platinum, copper, silver, etc., is called thermal resistors, and the temperature measuring element made of semiconductor material is called thermistors. Next, let's familiarize ourselves with the commonly used materials for thermal resistors. Most thermal resistors are made of pure metal materials, with platinum and copper being the most widely used. Platinum resistor has stable physical and chemical properties in high temperatures and oxidative environments, and it has good process performance and is easy to purify. It can be made into very fine platinum wire or extremely thin platinum foil because platinum possesses highly stable physical and chemical properties, strong reliability, and high measurement accuracy. Platinum thermal resistors are commonly used in high-precision temperature measurement fields such as laboratories, medical settings, and aerospace. In addition to platinum resistors, copper resistors are widely used at room temperature. Due to the high cost of platinum, copper resistors can be used as a substitute in situations where measurement accuracy is not critical and the temperature range is not extensive. This helps reduce costs while meeting accuracy requirements. Copper resistors are suitable for medium and low precision temperature measurements due to their nearly linear relationship between resistance and temperature, large resistance temperature coefficient, easy material purification, and low cost. Iron thermal resistors have a higher temperature coefficient of resistivity and higher electrical resistivity, making them cheaper but suitable for a narrower temperature measurement range. They are generally only used for low temperature measurements, and thus, are less commonly employed in practical applications. Nickel-iron alloy resistors are thermistors that measure temperature based on the characteristic changes in resistance with temperature. They have a high temperature coefficient, long service life, and good corrosion resistance, and are widely used in temperature measurement devices such as thermal resistor sensors and thermocouples. Platinum thermal resistors and copper thermal resistors are not ideal choices for measuring low temperature and ultra-low temperature, so some innovative thermal resistors, such as indium resistors, manganese resistors, and carbon resistors, have gradually become ideal choices for measuring low and ultra-low temperatures in recent years. What is a thermal resistor temperature sensor? A thermal resistor temperature sensor is a type of temperature sensor thermometer that utilizes the principle of the variation in the resistance value of conductors or semiconductors with temperature changes. Thermal resistor temperature sensors are commonly used temperature sensor products that leverage the principle of the change in resistance value of conductors or semiconductors with temperature for temperature measurement. They have advantages of stable performance, flexible use, and high reliability. The structure of thermal resistors is relatively simple. Generally, the resistance wire is wound around an insulating skeleton such as mica, quartz, ceramics, or plastic, fixed, and then covered with a protective sheath. Thermal resistor sensors typically consist of thermal resistors, connecting wires, and display instruments. Thermal resistors can be connected to temperature transmitters to convert temperature into standard current signals for output. When using thermal resistor sensors for temperature measurement, the measurement circuit generally adopts a high-precision bridge circuit. However, since the thermal resistor is usually located far from the measuring instrument, the lead wires of the thermal resistor have a significant impact on the measurement results. To eliminate the measurement error caused by the change in the resistance of the connecting wires with ambient temperature, Thermal resistor temperature bridges usually employ 3 lead wire configurations: the 2-wire system, the 3-wire system, and the 4-wire system. Applications of thermal resistors. Firstly, thermal resistor thermometer is commonly used in industrial temperature measurements, where platinum resistors and copper resistors serve as sensitive elements. The bridge circuit is widely used in measurement circuits. Secondly, thermal resistor flowmeter uses 2 platinum resistor probes. Our T1 is placed in the center of the pipeline, and its heat dissipation is influenced by the flow rate of the medium. In this lesson, we mainly studied the definition and characteristics of thermal resistors, commonly used materials, and applications of thermal resistors. After class, please explore the various applications of thermal resistors in daily life to deepen your understanding of the content covered in this lesson. That concludes our lesson for today. Goodbye.